Very good morning to everyone. Today we are going to study about Friedel-Crafts acylation of benzene. We all know that it's also a electrophilic substitution reaction of benzene. So here electrophile is this one. This R single bonded with carbon with double bonded of oxygen. Okay, so this one is our electrophile for Friedel-Crafts acylation of benzene. Now this R value means here is this R value is supposed to be any hydrocarbon like CH3, C2H5 and it's go on. Now let's go for one example. So here is our benzene and our reactant which will be go for fusion in presence of anhydrous AlCl₃. We all know that it's a Lewis acid and act as a catalyst. So after fusion we get one electrophile and another one is nucleophile. So this one is our electrophile. Go for attack of benzene and another one that is nucleophile captured by our Lewis acid, and finally we get our desirable product, that is this one, and along with a side product. Understood? Okay, now go for its mechanism. So for mechanism, first step is generation of electrophile. So this one is our reactant which will fused in presence of AlCl₃. Okay, so it fusion take place like this, and we get one electrophile which will go for attack of benzene, and another one is a nucleophile which will captured by AlCl₃, that is our Lewis acid. So this thing will happen in generation of electrophile in the first step. Next, attack of electrophile. So here is benzene, here also fusion or heterocyclic cleavage is occur like this in presence of our electrophile. So we get like this intermediate structure at the end of this stage. Okay, now comes for our last step, that is removal of old electrophile. So here it is our intermediate we get. Now in this carbon atom, in this position, the carbon atom have one hydrogen atom which will leave the ring by donating its electron to this carbon and satisfy its electron deficiency, and finally it's left as a nucleophile. Now this nucleophile will satisfy by AlCl₄ complex which will donate its extra electron to this hydrogen atom which will already present in our solution. Now finally we get ACl, that is our hydrochloric acid, and then AlCl₃, as it is same cause it's a catalyst, and finally our desired product, that is this one. So it's a 1-phenyl ethanol. Okay, fine, understood. So up to this much all about Friedel-Crafts alkylation and acylation. Now we have to discuss about some more important questions from alkylation, also from acylation as well. So starting from question number 1, just complete the reaction. So this is your question. Okay, let's see. This one is our benzene, this one is our reactant, and here we are using FeCl3 or ZnCl2, any one of them, as a Lewis acid. So what will be our their product? We have to find out which will our product. Understood? Okay, so our answer will be like this. Here it is our benzene, and this one is our reactant, which will go for fusion in presence of our Lewis acid. So one is electrophile, another one is nucleophile. So this one mean electrophile will go for attack of benzene, right? But some students little bit confused, and I'm sure that they thought today's sir is explaining the mechanism totally wrong. Is it not? Why? Because this one is a 1-degree carbocation, and there is a possibility for shifting this carbocation from 1 degree to 2-degree carbocation. Here it is. For providing better stability by rearrangement of carbocation. Is it true? But actually here no rearrangement will occur, and our desirable product is this one. But why? If you seen that I am using FeCl3 or ZnCl2 as a Lewis acid instead of AlCl3. Now there are lots of Lewis acid are there in our chemistry. Their work is same, but their capability is different. If you observe that I will cover all the substitution reactions of benzene, what I have done in previously, by using a single Lewis acid in maximum cases, that is AlCl3, right? So that is the reason you can use any kind of Lewis acid for substitution of benzene, but they have different features with it, like this one, this FeCl3 and ZnCl3. They cannot rearrange the carbocation. Actually, if you go for its mechanism, you find that here is no carbocation is produced. Yes, here is no carbocation is produced. So if we go for the mechanism, so here this reactant making a coordinate bond, with this Lewis acid, instead of breaking the bond properly, just sharing its lone pair, this chlorine having lone pair with it, so it will just share its lone pair with the Lewis acid instead of breaking this bond, and it's become delta positive and delta negative. So this whole complex is go for attack of benzene, and after that the extra part means this part will be removed from the ring. So this is why I am trying to use a single Lewis acid, that is AlCl₃, most reliable one rather than others. So I recommend it to all of you, use this AlCl₃ in all your examples where it is applicable, and far from others Lewis acid. Just stop for experimental works. Don't make it complex. You can use any kind of Lewis acid, but on the other hand, you have to memorize then lots of things like this. Who doesn't know that FeCl₃ and ZnCl₂, it can be able to rearrangement of carbocation, and also it not breaking, means fusion is not there in presence of this FeCl₃ and ZnCl₂. It's just sharing its lone pair through coordinate bond. So this concept you have to know. Otherwise if you changing the Lewis acid, their capability you doesn't know, so that will be problem for you. Okay, understood. For today that is enough. We are continuing from here in our next class. So until, thank you.